for my demonstration, I hope you use your own data and see what interesting thing will come out from your simulation. I think actually you should do it now, because after I demonstrate this, I will ask you to show and tell your plotting. Okay, you use if you still remember, you can import CPAS UI from CPAS.UI, import UI, and then UI equals to UI.selector. Okay, you do this for your data, and I do the one provided by Jimmy. I put this code to the chat for your convenience. And then you remember, you can use UI dot use a path first. UI dot grid tab, okay, this file, and then you will print a path. And then for you, you can just read this long thing up to this level. It is to the level of directory of grid.nc. But as you will see, okay, here I will use Jimmy's grid.nc. Okay, you use your grid.nc. And then, okay, this is a path. You can go straight checking something like output. So on Excel, for you, UI dot output NC file dictionary. It will be a long thing, but okay, let me print it out first. You may see something like this. This is the level of the directory up to the grid.nc file. And then under it, there will be one RSIM subdirectory. And then one very long ID, one long ID for one job. Perhaps you can see that this is something like a date, the date you order the job, something like that. And then there will be an ATM subdirectory level. And then you will see a large number of output files. Okay, so this is what you should work using your own data. And then I continue to use Jimmy's data. So this is the path, you sort it out. And then you can use this wildcard star here. And then use MF, open MF dataset to open all output data. And then you distract, Jimmy told you last time. And now I suggest you to also use chunks I have just introduced. And you may use the track, you don't specify it first and check the dimension, and then you determine the number to use. For now, I have tracked it before, and then I use the n cells dimension, and then 10,000 cells per chunk. So I can inspect it. I opened Jimmy's simulation data files. For time dimension, 37. This is for you. This is according to when you order the job, whether you specify every 3 hours it writes an output file, or every 1 hour you write an output file, or even shorter time. And then the more frequent you write an input file and the longer your simulation duration is, the more time slice you have. And then you will be handling big data in this Jupyter notebook. I hope you don't hit your resource limit. Or if you hit it one time, you know next time you order your job, you should change something to be smaller. And then these are the variables you specified, or if you didn't specify, just the set of default variables. And then for each variable, if you try to look into it, okay, here are the data cut into chunks. And then for me, my trial for this real case data will be a larger number of chunks. And then if we pull it out, then the task software will break it into 800 and something tasks. So hopefully the Jupyter notebook can still handle it. Okay. The next step, import these modules. You will see import holoviews as HV, and then import some GeoViews features that you will use. One more thing, you have to import some data shader that will also help you. And then just for this module names, what modules are involved, you just copy my code. It takes some time to import these large number of modules, and then you will see you are using more RAM. Okay, here is the code for plotting things out. You will be using a function called rasterize, which make the workload of rendering what you need to plot into a raster in the backend. If you do not use rasterize, probably it will run very long time, and then your browser may freeze. This rasterize is provided by here, data shader. HoloViews has integrated with data shader, and then together they provide rasterize. Okay, you use this function to order the backend to plot something. The thing you plot is a TriMesh, GV.TriMesh. So GeoViews is inheriting something from HoloViews, and together they provide GV.TriMesh. Okay, GV is GeoViews. And then this TriMesh class provide a function called from vertices. Here, it is triangular mesh. So the vertices of the triangles, as we have introduced, they are called duality. The vertices of the triangular mesh are the cell centers of the Voronoi tessellation. So we are using the longitude and latitude of the center of the Voronoi cells as vertices, and we pass them to the TriMesh. And then here are some functional programming after taking DS grid. Okay, the one we opened here, the grid.nc, open the data set and put it as a data set object called DS grid. for the geometry of your mesh. And then from such geometry, take the cell centers let long out. They are in radian. So you use functional programming to turn radians into degrees. And then merge the data set with another data set, which is DS output. DS output is what you have opened using this simulation output data, the large number of time steps with the simulation result of each time step. Okay, this is called DS output. So inside the DS output object, there are one variable called height 500 hectopascal, which you can actually check. It is this one. Okay, you are taking this out, and then there are multiple dimensions. Okay, you see time dimension and n cells dimension. So in one plotting, you can only plot one time slide. So out of this time dimension, you need to use iSelect here, and then you specify sometimes that. Here, I just show the initial condition, which is time step 0. After this merged the grid topography and the output data into one data set, we have to change it to pandas data frame, because this function expects a panda data frame. Okay, so this piece of code so compact, it will already provide the thing you can visualize. And then relabel is just the title of the plotting. And then aggregator mean in some processing it needed, so just use it. Okay, I try to run it. Is it running? Okay, this object is produced and then put to variable TriMesh. Next, if I just throw TriMesh, that's not that good looking, but I can show you. TriMesh, just visualize the plain TriMesh, and then, okay, this is the coloring representing the values of this variable. What the color map not present, so we better add this dot options color bar equals to true, and then the color map, and then this is too small, so width and height, and then I specify another projection, and then overlay with coastline, because I cannot recognize the location without coastline. Okay, here it goes. You see, if the same object is displayed in more than one cell and you change the options, it actually changes the other display. Okay, here is a visualization of, it is actually geometric height, but I said it is geopotential height approximately. And then you have this holoviews panel. This is a global plot. So this is the event DreamMe prepared for simulating tropical cyclone MPAS-A. If you remember, it is going from east to west here. So in this hollow view, actually, I'm not sure you have already used this feature or not. Box zoom, you enable box zoom, and then you drag, define a box where you want to zoom in. And then here it is, magnified, and then this Jupyter front end will tell the back end that you have magnified, and then you will see that the back end is busy for some seconds. For data shader, here, rasterize by data shader. Now data shader knows that you have zoomed in, so in the back end, it plots again, and then this zoom in plot will look even better because Jimmy probably used some variable resolution with refinement in this region. So the resolution here is finer, so the plotting looks a lot better. And then you can try zooming in even more, and then you see the back end is busy again. And then just several seconds, data shader has done a good job using back-end computational resources, and then send the render output to you. And then you may even zoom in and zoom in. This is somewhere in Philippines, I think. Actually, if you zoom in to be very in, you will see pixels. Actually, rasterize will turn what you need to visualize into pixels in the back end. But if the pixels are very dense, then the drawing is of high quality. So this is one